Hello everyone, welcome to today's webinar on cross-section templates. This is going to be an advanced webinar and it's for you guys, our support customers. So first to start, this is Erin. You've heard my voice probably a few times before on our webinars. I'm your typical resident webinar host here at Softree. With me, of course, I've got Matthew Dickey, our training manager. So thank you very much for joining today. This webinar, I should say, as a bit of housekeeping to start, it is not going to be posted to our YouTube channel. It will be available as a private link. So if you'd like to watch this webinar again in the future, be sure to check your email. You're going to get the private link available to you because this is, again, just for support customers. So our little agenda for today really is one of increasing complexity. So I am going to start with an introduction, talk a little bit about what cross-section templates are in RoadEng, talk about some key basic concepts, the foundation for cross-section templates, and then we're going to start to get a little bit more complicated. We're going to move into a few other key concepts. We're going to pass it to Matt in the software at that point. We're going to talk a little bit about the idea and the concept of layers. Layers as surfaces and layers for materials. We're going to talk about the concept of reference features as it applies to both features and alignments and how you can use reference features in your templates to control their positioning. The next one, we're going to talk about our point codes, a little bit about on how to understand what point codes are, if you want to modify them, and the role that they play in our final and most complicated topic. And I'm going to say, in all of our entire RoadEng universe of topics, cross-section templates are probably one of our more complicated ones. And our final topic here really is the most complicated thing you can do in our software. So potentially, if you are a newer user to the software, or if you don't really need to go there, we certainly encourage you not to go to this far deep place that we're going to teach you today. There's a lot of opportunities to leverage cross-section templates, existing ones that you can just customize and refine before you get into the deep end of the swimming pool, metaphorically speaking, with the custom development, building a cross-section from scratch. So again, our webinar is increasing in complexity as we go through, but hopefully you'll pick up some interesting tips and tricks and even just a better understanding of how cross-section templates work and how they're built and the potential capabilities of them. So let's go back to square one, start with the basics. Cross-section templates in RoadEng, what are they? They are essentially mini programs. And these mini programs inside the software really do define the road's geometry. Now, a road design without a cross-section template is essentially just an alignment or a line. So the cross-section is what's really building out that 3D aspect of it. The cross-sections can include parameters like your road width or corridor width. If you're using something that's not a road, you're doing rail, pipeline, again, it's going to define that width. The surfacing depths, the ditches, cut and fill slopes. It may even define benching, berms, and other elements that are being added to it. Now, I've got here on the screen a picture of our template editor. This is kind of like our sandbox. This is where we create and modify and define the logic that each of these templates contains. And here, it really, is a space where you can play with them, see what they look like before you go and apply them to your design. So this is just a view. If you clicked the little 4 grid down there, this shows this template that we would have customized or worked on as it's defined in the 4 different typical views: cut, fill, sloping right, and sloping left. So cross sections are really, really important. Again, as I mentioned, a road without a cross-section, just a line, essentially. So this cross-section template plays an important role in interacting with all the different components around those alignments. It's interacting with the topography. It's interacting with your subsurfaces. And in this particular picture we've got up here, we actually have a few different subsurface layers. These are different materials. And this cross-section template can be set up to change how it and adjust how it appears, and is like the slopes, for example, are going to adjust depending on the materials they're in. So these templates are really smart in terms of how they're interacting, and they're going to adjust dynamically once you've got that logic defined. It's important to note, and I'll cover this on the next slide as well, we talk about cross-section templates in terms of left side and in terms of right side. So if we look to this next slide here, you'll see, for example, the ditch has a left component and a right component. And so really we use the road center line and define our templates based on left and right. That way we can have different behavior happening on either side of center line depending on the conditions. So as I just alluded to with that mentioning of the ditch component, templates themselves are a collection of something called a component. Now, a component can be something like your roadway or your ditching or your slopes or perhaps benching. There's lots of different types of components. And each component is essentially a fillable form. And again, like I mentioned, you've got a left and a right side, but you do have the ability to copy and paste. So if you create, say, your resource left, you customize it, you set it up exactly how you want it, you don't have to go and do that again to make the right. You just simply would right click on it, copy, paste as right, and then that would have it in your template. The other sort of big piece here when it comes to components and the way that components are shown inside of a template. So here the template is the resource low volume. There's 6 components inside of it. The order of these components is really important. This is a construction order and it's typically done from center line out, but of course there are occasions where you'd want to deviate from that. So a better way to think about it is, how are the elements constructed? Which items are constructed first? And those are going to go at the top of the list. So again, constructed first at the top, constructed last at the bottom. And an example that kind of makes this one make a little bit more sense is if we had, say, a Jersey barrier. If we wanted to add that to our template, we would first, of course, need a road to build it on. So we would have all these other components in front and the Jersey barrier at the end. So templates made from components. Each component is like a fillable form. You can copy and paste because there's a left and a right, and the order is important. Okay, so we continue through these concepts, making sure I leave enough time for Matt here to get into all the good, fun, and more complicated things. Templates, as I said in our introduction, you don't necessarily need to go all the way to this idea of creating something from scratch. There's lots of different ways to create and customize a template. To start with, there's 3 defaults typically available in the software depending on your installed version. You can customize these, you can add to them, you can work with them. So those are the defaults available in the software. We then have our eLibrary available through that template editor dialog box. You can press the eLibrary and that's going to bring you to a huge section where you can select all the different components and bring them in and then pick and choose the ones you want to include in your particular template. We've got a lot of different components under each of the different folders and you can leverage those, customizing them further, adding them into the construction order of your particular template. The other way you can often get templates is through sharing. So you have the capability to save and share templates and set them as defaults. So this is kind of once you've got a template that say a colleague has, you just can borrow it, bringing it in through opening their template table and using it in your own project. So templates are really intended to be reused throughout different projects. So make sure to save, share them, set them as your defaults. And if you have any questions, this topic is not going to be included in any other detail besides me mentioning it in today's webinar. But if you have any questions on it, we certainly can provide a link to another resource that covers some more of these introductory template concepts. And then finally, in terms of the last method for creating and customizing a template, really is that complicated deep end things where we're going to build it from scratch. And as you can see here, the templates that we've seen before where we had the template with the components, it's getting broken down a lot further into fragments and to legs, and those all have logic defined within them. And we're going to talk about that part in the last topic of the webinar today. Okay, I'm almost done my section, but first, yeah, a couple more quick things. As we saw the templates, sandbox, we play with them in the template editor. Now, templates in that template editor are not automatically applied to your design. That is really, again, our sandbox. This is our toolbox. We haven't done anything with it yet. We use the assign by range function to tell the software which template to use, across which station range, and across which side. So you can define a template for a smaller station range, and you can have it applied to either the left, the right, or both. And then there's some other tools in the software to help you if you are working with multiple templates. One of those is the taper template. Now this one is a default template. It comes in your assign by range list, and it allows you to transition between templates. So in this case, transitioning between a rural one and a widened road, and then you can define the station range that you'd like to have it transition within. We also have a bridge template. This is a no-cut, no-fill template that, of course, can be applied to more than just bridges. It basically can be used anywhere that you want to disable all the earthwork and volume calculations. So the cross-section in this case displays just the ground line. So this is essentially what a template looks like when there's no template. It's just an alignment. So here, classic bridge case, but you can certainly use it elsewhere if you want to disable the earthwork volume calculations. And then finally, worth mentioning, sometimes you don't need to add an additional template. In the case of a widening, you could use something like an override. And again, we're not going to be talking about this one in the webinar, but if you'd like a link to the resource, we'll be sure to include that in the follow-up email, and you can check out some information about template overrides. Okay, let's talk a little bit more complicated. So this first part here where we talked about templates and components, a little bit of my introduction, that is what we typically expect a user of RoadEng to be playing with. Today's webinar is going to take us deeper. We are going to get into customizing this and being able to break it down into what we call fragments and then legs. And these are really the logic behind all the templates. It's hidden in these two deeper layers. So we would typically expect a programmer or an advanced user. And I think it's also important to mention if you start getting into this space, we will of course try to help you guys. But depending on the depth that you're in it, we often consider this outside of our technical support services. So if you're getting really, really deep into template building from scratch, we'll try to help you, but it's not technically within our scope. Okay, Matt, I'm going to be passing it over to you. We're going to talk a little bit now about layers, reference features, point codes, and then I'll come back to me for a couple more points before we get into that final development side of things.
All right, so as promised, we're going to poke around, and before we go right into building something out from square one, we're going to, I guess, cover some important concepts that, well, are important for everyone using templates, but they're even more important as a foundation as you get into template customization. So the first item on my hit list here is layers. Now with that, I zoom in here. So we see the cross section we have assigned, and as Aaron introduced, those different templates are assigned by different ranges. Here I've got some that are assigned on the left and some that are assigned on the right. But if we want to see, well, what's being tracked as what, we can go in here and we can right click and we can see, well, that hatched material is being tracked as subgrade. So when I right click, I see hatch SG. And here, if I hover over it, it also says fill SG. Now up here, we have surface 1. So that is important, because as we're just designing road, aside from the template aspect of things, it's pretty important to know how much different types of material cost, and track the volumes and all that good stuff. And we can also use those layers to control how things are displayed. So here in both my plan and my profile view, I have my surface 4 hatched with just that rock hatching. So my plan, I have that assigned in here. And in my cross-section templates, we have it assigned in here where we control the display by layer. Now, if we want to modify what layer is assigned for what, and we may, there's reasons we'd want to do that. So in this little example here, where I've got my rock fill, and then I've got a buttress or a blanket of material on my cut slope, be a pretty common thing to not want the same material specs for either side. But both of these on the E-library were assigned as that material being SRF4. So for that, I'm going to open up my template editor. And let's look at our buttress. So this buttress slope here, we can see, okay, surface 4. If I want to change that, I'll highlight the component that has the material that I want to edit, and I can just change that layer. So with that selected, I'll click layers, I'll click layer 4, I'll click change, and let's change that to layer 6. We'll hit OK, and we see I've got my layer 6 symbology to be something different. So great, away we go. I can do that on this one as well. We can treat them independent if we'd like, but yeah, we'll do that. And if we wanted to do it kind of globally for everything in there, we can do it at the template level rather than just at the component level. But here we're only wanting to control what's in that component. I did it there. We'll hit OK. We'll hit OK. And we'll see, well, we've changed that surface, and well, now it's showing differently in my views. And now I'm tracking that surface 6 material differently than my rock fill material. So I've got that defined in my data table. So layers are important as you work with templates. Hatching them, especially as you get into the customization stuff, is definitely a best practice because, well, it's a cross-section based model, and seeing what's being hatched for those different materials is going to directly influence what volumes are being tracked. So if we had something where maybe I messed up customizing a template in my stacked rock fill, wasn't targeting my merged surface, and we might have some double counting volumes, but here we can see everything's the way we want. Next item on my hit list is reference features. And this one, well, I'm going to show it as I'll show it as a alternative. So aside from just controlling our template geometry tabularly, so here, if I go in here, my road width is assigned as a fixed value. Well, there's templates assigned, or template overrides in this that are assigned where we've got our overrides, and on the right, I can see from station 675, I'm at that default width. Then out to 682.5, I'm transitioning out to be, well, from 2.5 meters to a 7.5 meter width. We carry that forward to that station, then we taper back in. So instead of doing that here, this is a great tool for kind of these standard dimensions, but if I had a widening that I wanted to make a little more irregular, I probably wouldn't use an override. I'll delete that. And instead I could use a reference feature. So here we're back to our default width. I'm going to, instead of using a terrain feature, I'm going to click add horizontal. And we'll just use an empty horizontal alignment for this. I'm going to shift it up to the top. And let's Yeah, I won't do anything too crazy. It'll be similar to what we had before, but I'll round out the edges of this instead. So I'm going to add my curves. So back in here, if I want my road edge to follow that line, we're going to go up to our templates, and I'm going to do this wrong to start. I'm going to say, well, instead of using these default values or overrides, I'm going to use a feature to define it. So I'm going to say, well, what reference feature? What is going to be that reference feature? So I click the little plus to get into my assign reference feature dialog. I'm going to say the geometry that I'm using is from horizontal alignment 2. Here there's just a center line in it, so that's the only thing I can connect to in that one. And then we'll say, well, let's use that there. So we can cycle through and we'll see that as we get through that, it's going out and it's going to wherever that alignment is that we drew. Now when I hit OK here, it's going to look like a little bit of a mess, at least that's what I'm planning on it. And there's another variable in here that we're going to want to mess with. So the variable that we're going to want to mess with here is this guy here, and that max offset. So how far away can the software look for a reference feature? So these crazy lines going all over the place, well, it's because the cross section here is extending out, and I've got it set to be 1,000 meters away right now, and it's tying to that. If we hem this in, let's say 80 meters, there we are. This is too far for that to, I guess, I'll put it in air quotes, see that reference feature, and then my geometry is set. And here, if I don't want to see the main alignment, we can see my road edge is following that line there. So reference features are, yeah, super useful. I think probably one of the more common things to use them for is independent ditch grades. But for this, kind of showing it to a group, a widening is nice and easy to see. So certainly fits the bill there. The next item on my kind of precursor hit list is point codes. Now, point codes, kind of like layers, super important, and they'll influence how we do things when we get into template customization. But if we kind of zoom in here, well, we can see this little cyan line here. Well, what's that? In my plan view, I have a template code being shown for my ditch inside left and ditch inside right. So we can control what we see based off of that. Similarly, road edge, so RE. That RE is the point code. So this little blue line that we have here is representing my road edge. Now it's great to know what actually defines that, and some of the things that you'll want to see won't be obvious. So things like DI, so ditch inside left and ditch inside right, are pretty consistent, but some of the templates on the E-library get kind of obscure and outside of the realm of what is commonly used, and you might have a point name that doesn't match up. So in order to find, well, I'm interested in this point here, what is that being called? We can hover. So just like we were doing before, we can hover and I can see the edge, top edge of my surfacing. So surfacing top 1, right, is right there. And we have that functionality when we're in here as well. So ST1, my ditch. Now here I don't have a U ditch, so I've got a ditch inside right and a ditch outside right. So DIR and DOR right on top of each other. So yeah, certainly pretty useful. And I'm going to use this as a bit of a, well, an excuse to talk about construction order, which Aaron introduced, and also tie that to point codes. So here, if I decided I want to have a no post barrier along the outside of my road, and here I think I can do it basically anywhere that I've got a rock fill. So I'm going to go on here, and we've got that. Now my 3 default cross-section templates are DF, RUR, and Urban. We'll go on to the eLibrary to grab something that's different. So here we can bring in just what we're interested in, so walls and barriers, or we can bring all those component folders in. Now I'm interested in this guy here, the Jersey barrier. So I'm going to copy that. I'm going to paste that into this template. So paste as right. I'm going to shift it up. So the construction order here, if my Jersey barrier is the first thing to be built, it could have an assigned elevation. In this case, it doesn't. It's set to go on the merged surface. So the Jersey barrier is built, and since the road and the rock fill and all that good stuff comes after, well, it gets built on top of the barrier rather than the other way around. So construction order matters. We'll shift that down to the bottom, so all the other stuff is built first. Now with this barrier component has, well, it can be attached to your geometry. So how is it attached to the geometry? Well, we've got a connection. And this one is connected to centerline, but there's a parameter in here that lets us specify an offset. So if we set that to 0, we can see that that is tied right to that point and going on top of the surface that's been built. For me, if I'm doing barriers, I usually don't like to have a fixed offset. So if you have something like curve widening applied, I'd often rather have that attached to a point code. And here I'd like that attached to that point code, the top edge of my surfacing material, so ST1. So we can go into connections and we can say, well, let's connect that to that point code ST1. Great, well, almost great. It's going to follow my road edge, but it's overhanging. So we could deal with that overhang a few different ways. We could say, well, how wide is our base? We can just use the measure tool for that. So we're at 0.8. And we could say, well, let's go 0.8, negative 0.8. I'm not going to do that though. We could also go in here and we could say, well, relative to ST1, let's add an offset, negative 0.8. Or if we wanted to be able to mess around with that base width and not worry about updating our parameters in 2 different spots, we could say that this offset is going to be relative to a parameter. So we've got base width in there as a parameter. I'm going to make it a negative offset. And there we are. So now whatever that base width is, which is assigned in here, is going to be applied for your offset. So that is template point codes. They're super useful for controlling templates, and we'll use them here later when we build a new template from scratch. Also useful for using existing templates. And then the other big thing that they're helpful for is displaying line work. And if you're doing something like summarizing staking notes or something like that, well, we've got a lot of information that is tracked relative to the point codes here, where you can see your X and Y coordinates, your elevation, offsets, etc. So yeah, point codes are a critical part of the software. I'll hand it back to Aaron here briefly before we dive into my next part.
Perfect. Thanks, Matt. So before we go into again, our metaphorical deep end, I just wanted to talk about and reiterate a couple of the concepts when it comes to the composition or the hierarchy of how templates are built. So we've covered most of those concepts. We're now moving into that development space. So with that, template components, building them from scratch, customizing them. Again, this is reserved for programmers. Of course, we're happy to do this. We've done lots of template customization on spec, or for advanced users. So Matt's been chatting and talking a little bit of those fundamentals. We've been playing sort of in that template and template component space. But in the next few steps, as I pass it back to Matt, he is going to press the customize button. And what that's going to do is it's going to expose fragments and legs, and you can create these from scratch. So again, we've got the templates, we've got the components, and then we can start to get into the customization of fragments. And these are going to tie together all those concepts of point codes, reference surfaces, reference features, surfaces, layers, materials, all of that plus logic. And really you can get into the weeds here. And this is really the composition of how every template has been built in our eLibrary. So breaking it down programmatically into the logic that is used for every little subcomponent, which we call fragments and legs, as it builds up. So with that, again, I'm going to go back to Matt. If you do not need to go into this space, if you can find a way to make existing components in existing templates work, stay there. Don't press the customize button. But if you are like Matt was once upon a time at a client, he was interested to understand the software better. He pressed the customize button. And to be honest, everything that Matt's going to show you here today, he figured out himself. So with that, Matt, I'm coming back to you.
All right, cool. So I've got a different design here, and I guess my goal is to start simple and just build on simple. So this example, we've got a haul road up out of a quarry. Right now, I've got my safety berm taken care of by a template component that's on the eLibrary. So as far as rules of thumb, you're free to, but generally check the eLibrary to see if there's something that does what you want it to do before just trying to reinvent the wheel and build something from scratch. Now with this, instead of using that template, I'm going to use this one that doesn't have a berm already on it. And we don't have to make it super complicated to get what we want. So templates can be intimidating if you try to make one that's really complicated, or they can be simple if you keep it simple. And if you're new to template customization, well, a great rule of thumb is to start simple. Don't just try to make something that does all sorts of different things automatically. It's always, it's always reassuring at the back of your mind, well, I don't need a bunch of logic. I can just assign one template to cover from here to there and another one to cover from the next station to following station. So let's start simple. And rather than doing any tough template customization, I'm going to start out by using what's on the eLibrary, but not using it because of the name or the description. So with this, I'm going to bring in my links. And I like links because they are, well, pretty simple. Usually if I'm building a template component, I start from a link. So this we have links and connectors, link offset. So we've got a slope and a dy. So a y distance, so a height. If we're building a berm, well, that seems like it's probably a reasonably good fit. We're going to paste that in here. We can see what we're dealing with. We can double click and we can customize it. So here I want to have a berm that's 1.2 meters high. And I'll make my berm slope 80%. Now, if I want to add a top to that berm, so a flat spot at the top, well, using something that I'm defining my distance based off height probably isn't very useful for that. So let's go in here and we'll grab in a dx and slope. So paste as right. Boom. We're going to change this to be 0.5 meter. And we'll change this to be flat. And for the back slope of this, considering we may want to have the berm slope to be sloped differently than my fill, we'll hit copy, we'll hit paste as right. And I'm just going to change this to be a negative slope. So if all I wanted was a cross section that had a berm that was with fixed dimensions, part of my subgrade material, and I wasn't really worried about portability, that ticks my boxes. I can probably get what I want out of it without clicking this customize button down here. Now, if this is something that I plan to use over several templates, or maybe I want to just make it easier to make adjustments. So for this one, if I want my berm height to be the same on the foreslope as the back slope, well, then it makes sense to, and I want to just control it with one parameter, then it makes sense to throw it all in a single component. And yeah, we won't make it really more complicated in terms of geometry or logic, but we'll just make it easier to work with. So instead of having 3 components here, we're going to get rid of those. I'm going to highlight that. I'm going to hit the customize button, and it's telling me that this stock component is changing. So Aaron introduced it, the idea that we had templates, components inside templates, and these parts are what folks that are customizing templates are going to manipulate. But they're also going to manipulate stuff at the component level that was just hidden when it was a stock component. We're going to go in here and we can see, well, it looks pretty similar to the UI before, but we have the option to add parameters, modify parameters, delete parameters. Yeah, so let's first change our name. We want to stay organized. And we'll call this webinar berm. It's also nice to add a description because, yeah, one nice thing about software is it's really easy to use parts from a previous project on a future one. So you may build something on one project and want to bring it in and use it later when it's almost long forgotten. So a description helps. And yeah, example berm for webinar to cover concepts. All right, so let's start manipulating our parameters. So dy isn't very informative on what that is representing. So I'm going to click modify and I'm going to change the name. I'm going to call this berm height. It is something that I want other users without customizing it to have access to. I want people to be able to override it, and I want it to be in project units. Now this is going to be a commonly used parameter, so there's no need to hide it as an advanced setting. And it's not a slope, so that works for me. Description, berm height. Oh, how else to describe it? It's pretty straightforward. Slope, berm slope, and fore and back slope of berm. This is a slope, so if I want that to be applied as a slope, it's going to have that checkbox toggled, and we'll hit OK. And then for this, I'm going to add a parameter, and we're going to add in another user parameter that's based off project units, and I'm going to call it berm width of top of berm. And here, so as you're going through this and things become more and more complicated, we can see that that one's not being used. So sometimes you make edits and manipulate stuff. It's nice to just at a glance see what's used or not being used. So this one will be in a moment. So below the component level, we have our fragment. So the fragment, I'll click properties here. I'm going to call this berm top. Again, just a best practice to stay organized. I'd like this berm material to be tracked as part of my subgrade. We'll have it check the target surface based off of the strip topo. So things like am I in cut or fill? Well, it's going to be relative to my topo rather than some other surface. And then when we're calculating our volumes, I'll explain this a bit more later, we've got our merge surface here. We'll hit OK. Then we've got our legs. So we'll click this, properties, legs. I'm going to call this TOB1, so top of berm 1. The height is set based off of that parameter. So that's great. It's a vertical distance that we're defining it. And this parameter here is a slope. So we're going up at 80%. It's being populated by the berm slope parameter. We're going to add another leg to this fragment. I'm going to call this one TOB2. We're going to set it as horizontal distance, berm width. And here, I'm not going to use a parameter because I want that berm width to always be set flat. So no parameter, it's just going to be 0 slope. Oh, and here, I was wondering why didn't that appear? And it's because I've got my width set at 0. So we'll go back down, our back slope, paste as new. Of course, we want it to go down, so we're going to set that parameter be a negative slope. And the name, we're going to call it bottom of berm 1. We'll hit OK. Now, if we want to manipulate something, like our berm height, if we want to change that 1.2 to a 1, we can change it, and it works. It does what we want it to. We don't have to change it in 2 different spots. And if we wanted to take that over to use on another template, we could just copy, paste, and paste that in. So yeah, we went from using links. Now we basically just took those links and put them in a single component and had the geometry controlled by a parameter. Let's, again, add a little bit more complexity to things. And well, sometimes for these berms, folks will want the actual berm material to be tracked as something separate. Maybe they're using waste rock and doing it after construction of the main road prism. So for that, let's do it. And again, I'm going to break something here before we make it better. So if I say, well, I want that subgrade material not to be subgrade material for my berm. If I want that to be tracked as surface 16, well, that doesn't look very nice. So there's, yeah, there's some stuff going on. So one, this volume is calculated relative to the merged surface, and this fill slope hasn't happened yet. So again, that construction order, where as far as the software is concerned, this doesn't exist, and the merged surface goes down to our topo. Now, the other thing here is this is going on the outside of, well, how is it connected? It's connected to our outside of subgrade. So there's no subgrade out here to connect to, so it's going off of there. And even if we did change this to be the outside of any surface, well, that doesn't look very good either, because we're probably not building this vertical dike out of our berm material. So it's just a matter of knowing it. It's easy to deal with, but we're going to be somewhat elegant in how we deal with it. So one way we could deal with it would be to just say, well, let's put a subgrade fragment that goes across the bottom, and we assign the variable. Great. For this one, instead of assigning a variable, if we change stuff, we don't want to have to calculate what that other length is ourselves. So we can include that as a parameter. Now this parameter is not going to be user editable or overridable. We're going to call it berm footprint. And it's going to be the base width of our berm. And it's going to be an expression. So with this, how wide is that base? Well, we know our height of our berm, and we know the slope, so we can calculate how far out we go from that attachment point to our, I guess the foreslope of our berm. So I'll go berm height, and I'm going to just copy and paste that over here, divided by my berm slope. And you'll notice I put that in brackets, and there's a reason I put that in brackets. And berm slope is looked at in the software's eyes at this point as being 80, so not 80%. We're going to divide that by 100, make it a percent, and there we are. So it's saying 1.5. I'm going to just use the measure tool. Am I lying to you? Well, our dx is 1.5. So usually as I'm doing this, I'll check my measurements incrementally and not just do it all at the end and have to sift through a bunch of stuff versus a little amount of stuff. So let's go back in here. Now, of course, we've got a foreslope and we've got a back slope. So we can probably just take this whole thing and multiply it by 2. So, great. So we're at 3, but if we just left that, we'd be forgetting about the berm top. So we'll throw in a plus, and we'll grab that berm width. So there we are. We know what our berm footprint is. So next, well, we can probably throw a component in there. So, or sorry, a leg in there. So let's make that unused variable a used variable. I'm just going to copy this, paste it there. I'm going to change this to be subgrade. And well, I only want one leg here. I'm going to change the name to be BOB2. It'll be a horizontal distance, and we're going to use that berm footprint. Again, we're keeping it flat so we don't have to worry about a slope. So we've got that. And let's attach this to, oh, oops. Make it on the right. So we've got that. So now we've got a base for our berm to go on. That base is being calculated first. So we've got our subgrade goes out to there, and our subgrade build slope goes off of that. And yeah, everything's hunky-dory. So our berm is being tracked as surface volume 16. With this, if we had messed up our order, well, we can see it's not very nice looking. So again, order matters. So in that kind of incremental steps of complexity that we've added to it, instead of just having a single material type component, we've got a 2 material type component. And instead of figuring out each time how wide our berm is, if we say change the height, well, it's automatically being adjusted for us because this width is an expression. So we can keep running with this, and I'll try to be somewhat cognizant of the time, but let's add a little logic in here. So with this right now, this whole thing is fixed. And if I wanted something that my berm was excluded, if I was in cut, we could do that. And this is something that we could probably lean into quite a bit and have a bunch of logic to account for kind of different nuances of where things are measured from. But we'll just do one, and we're going to check if the outside of our berm is in fill. If it is, we'll keep it. And if it's in cut, we're going to get rid of it. And for this, I'm going to start out in something new to, I guess, illustrate what I'm going for here before we add in the other components. All right, so this berm width that we have, let's change this, or sorry, not berm width, the footprint. Let's change this to be a private surface. So what that private surface does is it's not being used in any of our volumes. It's just going out there. And usually if we're using a private surface, it would be in the sense of what we call a probe, where we're checking for a certain condition. And this one, I'm interested in this point. So our berm width is in cut or fill. So I'm gonna just change this name to be probe 1. So if probe 1 is in fill, I want this to exist. If berm 1 is in cut, I don't want it to exist. So in this leg level, we have a few checks, and I'm obviously not going to go through all the different parameters in template customization today, but I'm going to turn on this exclude if it ends below target surface. So exclude if that's in cut. So it's there when it ends in fill. It's not there if it ends in cut. Now, what is it checking against? It's checking against the topo. So great, we have part of our check. Now the problem with this is if I just take what we previously have created and attach it to the outside of that, well, I would get a berm floating off here in space. So really I want this to check what's there. And from that point, I want it to double back and go back to where we have the component attachment point. So I'm going to make a second fragment. So again, I'm going to change the name here. So with this, instead of going and being attached to my component attachment point, or another common one would be the outside of template, I want this to be attached to a specific point code. So I'm going to attach this to PB1. So that starts there. And instead of going out, I could say, well, let's make this go back in on itself. And we could start out right from scratch. So, and now with this part, I don't want that check. So it goes, if that exists, it goes back to there, and I could attach from this point code. Now in this case, I'm going to change it up, do something different still, and just more of an excuse to show something else. We can have 2 attachment points. So this component can start there, but I can tell it to attach to another known point. So I can say, well, attach to my component attachment point for tie 2. And this is nice, so if you had something that wasn't just flat, you wouldn't have to calculate what it needed to be. But we can say, well, adjust it if it has multiple attachment points, and great, we've got that in there. So PB2, I'm going to take this, I'm going to paste this in here. So paste as that, and instead of just going on the outside, I'm attaching it to PB2. So PB2 only exists if PB1 exists, and PB1 exists only if it's infill. So that goes away. We'll do the same thing for this guy here. So that fragment will attach to PB2. So it's there and it's not there. So we've gone from just having a template that, well, was a series of links to give us the geometry we want to, as one surface to, again, instead of that, we put it all in a component so it's easy to move around. And we have to muck around with fewer parameters if we want to change something. Then we made the berm material a separate surface type. And then we took it a step further by adding some logic in there and controlling where that berm is attached based off of the point code, and more importantly here, the presence of the point code. So with that, my spiel is done. We can open it up for some questions. Hopefully I didn't go too far in the weeds there, but
Oh, we definitely went into the weeds on that one. So while you think up your questions, I thought we should probably acknowledge the fact that we are doing this webinar on Halloween, sharing off something that one of our marketing manager cooked up, which is how to carve a pumpkin, civil engineering edition. So drop those questions into the chat. As a reminder, you are going to be anonymous, although this is a safe space of RoadEng users. Feel free to ask anything you want. Yeah, okay, couple questions coming in. Matt, ooh, I like that they're simple too. How did you control your hatching in the template?
all right.
And I'll let you get organized with your screen. Give someone else a second to read our funny little Halloween poster, and I'll get ready to pass it back to you.
All right, I'll for my hatching. I've got that other one already set up. So, all right, I've got. I'll steal the screen here.
Okay, it's coming back to you.
All right, so the hatching that I have here, the settings are going to be well, controlled in the options for the various views. So here I'm actually including the hatching in my plan view as a shading. For the sections though, section options, templates. Right now it's showing me all of the surfaces that are assigned in my design. If I want to see all the surfaces, I can click that. And so if I want to change my surface 6 from being that to being, oh, what do we want to use? Sure, that. We'll just change it here. We'll hit OK, and we'll hit OK. So there we are. We've changed it there. Here, if I want to change what surface 6 is showing in my plan view, go down there and do the same thing. So pretty easy, straightforward to get in there and change the geometry as you wish.
Awesome. Well, this looks like it's another relatively easy one, but it's all about naming and layers. Do you have an ability to change the name for layers?
Yeah. Let's see here. So let's call surface 4, something else. Oops, wrong button. So surface 4, let's call it rock. So we've just changed it there. Yeah, so just a matter of templates, materials. You can get to this material section another way as well. We can go in from this point. But yeah, it's just a matter of, oh, I guess we can't access it there. It's just a matter of clicking it, selecting the layer you'd like, and then yeah, you can change what's showing as the abbreviation or the description. And you can also assign specific materials in terms of ground types to those layers here as well. Hopefully that tackles that question.
Awesome. Well, with that, we are officially out of time. Thank you guys for coming today. Again, I kind of want to reiterate, if you don't need to go to the deep end, don't go there. However, great to have an understanding of how templates are built, the foundation that they sit upon inside of legs and fragments. And if you have any questions as you potentially look to do this yourself, do reach out. Just know that full customization and development of templates is really outside of software's support scope, but it is something that we've done as well, as I mentioned, on spec for clients. If you have something really specific you want, certainly can leverage our in-house services, and we're happy to provide an estimate for those. So with that, happy Halloween, everybody. Have an awesome rest of your day. Again, yeah, this video is coming to you as a private link for YouTube. So if you need to look at it, yeah, take a look for that link that's going to be coming in an email probably tomorrow, and you can get access to the video again. Matt, any final words?
Yeah, actually, I do have something that I forgot that I wanted to say, because when I was learning it, it helped me a lot. I'm not usually one to click the help button. Some of this stuff is a lot easier with just a tiny little bit of guidance. So template customization, I am a huge fan of F1, and a lot of the stuff that I've covered here in kind of this really fast run through, yeah, you can look at it in different layers in the UI. So if I'm doing an expression and I'm interested in how the expressions are formed, well, in that part of the UI, with it being current, I'll hit F1 and I'll dive in there and see, oh, okay, I'm using the wrong argument or something like that. And yeah, it's a great resource. With that though, I'm done. Thanks for listening, everyone. And yeah, have a great Halloween.
Happy Halloween. See you, everybody.